And now for tonight's program, Bats of the Central Coast with our presenter, Bill Haas. So this is a little bit about Bill. Like many Audubon members, Bill started his natural history adventure casually watching birds. His journey, though, started at age 4 when he identified his first and still one of his favorite birds, the blue jay. Later that year, he was attacked by a Canada goose while visiting a small neighborhood pond, and was subsequently bombarded by a gray catbird while looking at his first found nest in the company of Dr. Swift, a scientist at the American Museum of Natural History, who actually lived down the street in a big greenhouse surrounded by woods. A couple of years later, and a few degrees later, he joined the Peace Corps and was sent to Belize, Central America, and began a teaching career that also included the development of a new science curriculum for a nation just achieving its independence. After developing the country's first field ecology course for the Belize College of Arts, Sciences, and Technology, armed with mist nets, field glasses, and an enthusiastic group of 12 students, and access to the mountain pine ridge, he was left with a puzzle: what to do at night with enthusiastic students, a bunch of mist nets, and no nighttime plans. The rest, including this program, is history. So I'd like to welcome Bill to tonight's evening program. Bill? Are you there, Bill?
So hello, everybody. I think we're okay.
I think we are.
Good. So welcome, Bats of San Luis Obispo County and the near environments. And this is a special presentation, an amalgamation of about 6 other presentations made specifically for the Morro Coast Audubon Society. And as you'll note, it's an Ajax presentation. Next slide. Oh. Oh, back. No, front. All right, there we go. Stop. So I'm the director of the Central Coast Bat Survey, which has now become the Central California Bat Survey, because we've been asked to do bat surveys from the coast all the way into the desert on the Mojave Desert, both the east and west sides. And our general study area had been northern Santa Barbara County, southern Monterey County, and all of San Luis Obispo County. Most of the data that I have has been derived, and most of this presentation is based on the data that I've collected here in San Luis Obispo County. And we originally had a group that would meet monthly. And people have jobs, they have families. And so we didn't get together as much as I'd like to. So I still want to disseminate information about bats. And so I've just begun 2 projects: the Blatantly Biased Bat blog, which I will send out to Audubon the link to that. I've actually already recorded my first 3 podcasts, and they will be dropped next week, as a matter of fact, for their first public listening. And then also I'll be doing a monthly podcast called Bat Chatting, where I'll talk with local bat experts. I'll talk to other people within the state of California who work with bats and who can inform us on any number of things. And the Bat Chatting site, which will be on rss.com, will actually allow people to ask questions, but also we'll have weekly quizzes, believe it or not, on bats. And we'll have an acoustic recording that you can take a guess on. And then finally, we're developing a citizen or a public bat scientist group in order to conduct bat blitzes. And bat blitzes, you've probably heard of blitzes, but if you haven't, basically what happens is you pick a time, a date, and people go out to various areas. Our bat blitzes will be in the 3 areas that I've just mentioned, Santa Barbara, Monterey, and San Luis Obispo counties. You'll be given a bat detector and instructions and spend about 4 hours in the field. Typically in the summer, it'd be from 8 till midnight. Collect your data, give the equipment back to me, and then I go ahead and analyze it. So let's move on to the next slide. So here is basically a good slide, I think, for people to see, because it's hard to imagine what that thing is made of, those leathery wings, that odd tail and such. And there's 2 things I want to point out. The bat on the left, notice that the tail does not extend beyond that flap of skin, which is actually called the tail membrane, or the urofemoral membrane. And notice the bat on the right has just a little nubbin of a tail that proceeds past the membrane. And the reason I'm pointing that out will become clear in the next slide, because people love to identify things as birders, and I'm assuming most of you are birders. That's kind of one of the pleasures, finding a new bird or identifying a first bird, or that sort of, or your first outing as a birder. But people come back to me with all sorts of suggestions, and I might as well break the news. The most common thing people see is a little brown bat. The problem with that is little brown bats, the little brown bat is a specific species. Unfortunately, it's one of 7 little brown bats in the generic sense that occur in the area. So I unfortunately have to break the news that they almost never see a little brown bat, but one of the others. The others will be made clear later in this discussion. But anyway, so just take a quick look, see where the thumb is, see how the fingers, it's maybe not what you would expect. But once you look at it, you go, oh, I think that makes sense. And almost all of these things, of course, the wings have functions. The wings, of course, for flying, and the ears for listening. The nose leaf that they point out, which may or may not be as clear in these images, help in gathering the ultrasound that the bats emanate either through their mouths or their noses. And so it makes for a very nice picture of, okay, now that makes sense. But I think the big thing is to see that those wings are actually an extension of the hand connected to the body. All right, let's move on. So this is what I was saying. So later in the program, we're going to talk about kind of your regular bats, which are the Vesper bats. And then we're going to talk about free-tailed bats. And if you remember that little nubbin on one of those bats, the bat on the right in the previous slide, that's not the equivalent of what someone is talking about with the free-tailed bats. And so I wanted to have this picture. Notice everything else is the same. The thumb is there. It's funny that this author decided to put sharp little teeth. I don't know if that's a warning or whether it's just a summary. But anyway, I think the whole purpose here is to show you what a free-tailed bat is, because when we get into the groups of bats that occur on the Central Coast, that's one of the 2 groups. All right. So here is I think the typical, and even there's one thing I might even add to this, but notice that the phenology of bats. Usually we think of bats as hibernating, and we can see that, of course, without foliage on the trees, you're probably also going to lack the insect volume that a bat needs to survive, or many bats need to survive. Let's do one click and add. Okay, so now we can see, yeah, so you think that either it's hibernation or migration. Here on the Central Coast, we're pretty lucky with weather, although many of you might not agree after our weather in the overly used triple-digit term that our local weather people say. There are other words for triple digits like century, 100, that sort of thing. But notice I've added migration. We don't have that much migration, but I do want to tell you that migration can be any number of things. Some bats actually migrate north during the winter. Some bats migrate up to higher elevation, again, during the winter. And then some do the traditional bird-like migration going from north to south. And I think you can figure out that the migration to higher elevation or to more northerly climates is all related to the fact that bats who migrate in that perspective have to hibernate. And so they're going to an area that's colder. And even though you might think that our local weather gets certainly chilly, perhaps cold on occasion, it is not too cold for many of our bats. And I have bat detectors at my house all year round, running basically, as they say, 24/7, except of course they don't pick up anything during the daytime. But we have bats active throughout the year. And on any given relatively pleasant or warmish day during the winter, I'll detect as many as 4 species of bats at my house all the way through the full year. But here's the real story. Next. So this is probably one of the more interesting things, and it's not as unusual as one might think. But notice that I've added here mating on both the winter side and also in the autumn to winter. So I'm sorry, so winter to spring period, which is where you might think that bats would get together before they raise their pups. But bats do some interesting things. So spring mating often involves swarming. And that means that some places bats are attracted to a certain area where they're very social animals. I didn't mention that earlier, but bats are very social. And one of the socializations is that they get together in these large, hundreds to thousands of animals, and they're called a swarm, and they mate. And those are often, they also can do this individually. Males can seek out females, females can seek out males, and more on the proverbial one-on-one basis. And then that leads to the traditional pregnancy and then birth of the pups. But there is also the possibility of mating and also swarming in the fall, where there's two interesting types of biology that take place. And one is called delayed implantation, where the female stores the sperm until spring. And then there's a second strategy, which is basically can store the sperm from the male over the winter, and then in that sense self-fertilizes, of course, with the male sperm once spring comes. So the mating rituals of bats is intriguing, but one of the more interesting things is, although it's just outside of our Central Coast area, there used to be concerns about the Mexican free-tailed bat, where it was lost for several months, up to maybe 6 weeks, not quite 2 months, in the springtime, until a very famous bat biologist whose name is Pat Brown found that, oh my goodness, there are tons, almost literally tons of Mexican free-tailed bats in the Oxnard area. And what was happening is that the free-tailed bats were leaving the northern LA County and Ventura County, and heading to the coast where they would form these giant swarms and do their mating. And then 6 to 8 weeks later, they're back at their normal roost sites or their maternity roosts. So let's go on to the next site. Oh yeah, so we'll add, of course, I should have mentioned this, migration does occur, but less than you might expect for our bats. Next. So when I give presentations, I like to give my employees the benefit of all the work that they've done. And this is our lead bat biologist, who apparently is fascinated by things that are colorful and that move. This is Ajax. He's the producer of this presentation. He's also the weirdest dog because he loves fireworks. And here he is actively monitoring at a local bridge site up in, actually up at the Bradley Road Bridge, just outside of San Luis Obispo County, just on the other side of Camp Roberts. And he stared at that. That's just an iPad, and that red thing is a ultrasound microphone. And he just stood there on guard for about an hour and a half, and then we left. Next. Next slide. Back. Gotta go back. Okay, now we go one ahead. Now one. All right. So this is what you all see when you go birding. And this is, of course, what you hear. If you'll hit the slide forward, you'll hear it. Okay, well, we'll just go right through it. You shouldn't have to play that. All right, well, so we'll go to this is what you see when you go batting. Next slide. And then listen carefully. This is what you hear. All right, next slide. So, because you can't see them and you can't hear them, what do you do? So here's just I think it's a pretty comprehensive assortment, but here are some of the ways in which we study bats. So birders should all be familiar with the process of mist netting, and the same way that birds go into mist nets, bats go into mist nets. We also do some spotlighting. We use acoustic detectors, and acoustic detectors basically are a combination of a microphone and a recorder. The microphones are specialized to pick up, and in this country, most of our bats produce sound in the 20 to 120 kilohertz range. Most humans do not hear at the 20 kilohertz range. So aside from just a couple of bats, there are 5 or 6 in the West that one could hear if one had good hearing. They're under 20 kilohertz. You need basically specialized equipment, and hence that previous slide where, of course, you could neither see nor hear anything. Then we do passive surveying. So if you look up in the right-hand corner, that is if you notice, there's a pole, there's a wire, and at the top of that pole connected to the wire is an ultrasonic microphone, and that is at the edge of a marsh. And bats love to fly along edges and through corridors, and there is a willow corridor along the edge of this marsh, and the bats come nightly and soar over it. And within 100 feet of that microphone, any bat that emanates ultrasound, that microphone will pick it up. Somewhere down in those grasses is the actual recorder, which you'll see on the next slide. Not yet, though. And then here's just a nice bucolic scene. Actually, it's a golf course in Paso Robles, and that is my wife, who is using the bat detector as we were getting ready to do a night survey at that pond, which we collected data from 9 different species. from that golf course. And so what are we looking at? And anyone who's going on the 2 field trips, what you see on the right, which I'll also address later in more detail, that's the kind of thing that you're going to see, and you won't necessarily be able to interpret those yourself, but with the help of the Android or iPad, we'll be able to tell what bats are there, and you'll start to actually get an idea of whether at least it's a high frequency or a low frequency bat. So we also do infrared videography, which I think you'll see on the next slide. We do data sharing. There are 2 major programs, North American Bat Survey, NABAT, and then Bat AMP. And so people ask me for, hey, what species do you get over there on the Central Coast? And I go here. And hey, what do you guys get up in the redwoods? And they go here. And they send data, we exchange data. And the bat group is a very cooperative group of people. I think we all know we're relatively weird, so it's easier to stick together and help each other out. And there aren't many of us. And the funny thing is, or the better thing is, or the best thing is that right now, there are probably now a disproportionate, where it used to be about 80-20 male researchers to 20 female researchers. The tables have turned, where currently now in college and in post-college studies, it is now about 70% women and about 30% men who are now studying bats. That's pretty impressive, when I think you think that a lot of people don't like bats for some reason. And obviously we have loads of stereotypes. And so the bat women are undoing many stereotypes, not to mention doing great work. So there's other things. We do active roost monitoring. You have to find a roost first. We do emergence counts, which means you sit under a bridge or at a cave and you literally count as the bats come out. 1s and 2s when possible, or sometimes in the 20s and 30,000s if you're at like Bracken Cave in Texas. There's also something that I have not done, but the woman I mentioned earlier, Pat Brown, who found the big swarm of free-tailed bats, she does actually a lot of telemetry, which is very cool. And she flies around in a helicopter chasing bats that are radio tagged. So that's just a nice summary of the kinds of things that we do to study bats. Next slide. So just some more of this. Left-hand side, that was a great job. Hey, I've got bats in my attic here on Vine Street in Paso Robles. I need a bat survey. Well, I know just the person to do that. And that's the same equipment we'll be using in the field on Tuesday and Thursday nights. In the middle, that's one of my desert study sites. Again, you can see the post at the top is the microphone. And over on the right, there is the actual collector. And these things are highly sophisticated. And in this case, for this purpose, is that black object sticking out of the top of the bat detector is the same microphone that I would put on top of a 10-foot pole. And that wonderful bat detector does all sorts of things, including recording. It also turns on and off on its own. It goes into battery saving mode on cold nights. And it also has built-in GPS, so that if I'm traveling around and I'm driving out in the desert, it tells me where that bat was that I didn't see or hear, but that I recorded. Over on the left, that is a different type of microphone. That's actually a broad sort of, I believe it's a unidirectional microphone, and that's attached to the car, and you basically can do your survey driving about 5 to 10 miles an hour. It's hard to do on a hill, but we fortunately don't have a lot of hills where I work. So, and all the time, that just picks up bat recordings. And the middle bottom, that is actually one of my UV cameras. And I was setting it up to detect whether there were bats at that bridge, and if there were any holes in the, that was to protect an area that was going to be worked on. And we wanted to make sure that bats were not going in or out. We felt that if they were in there, we needed to get them out. And if they were out, we didn't want them inside because they would probably get trapped. All right, next slide. All right, so this is another thing. I always get questions about bats and where they live and such. But it's literally anywhere and everywhere. They obviously, trees are a popular spot. They hide behind bark and tree hollows. They hang from vegetation. They are also found fallen trees and logs. Bats do not always hang up in caves or in crevices in rocks. Obviously, bridges are very popular, and as with the person on Vine Street in Paso Robles, theirs were in the attic. People with Spanish-style roofs, the tile roofs, if you don't do something, you'll get bats. If you don't get something to keep them out, you'll get swallows or bats, or unfortunately English sparrows. Or English, is that what they're called? Yeah, I think English sparrows. But caves, mines, rock crevices, rock slides. And I think the more interesting thing is that what you might not expect, if you're driving along and you see you're on a bridge and there's a stream, and then down below are a bunch of rocks that are sort of buffeting the structure. Bats actually will go into those rocks. They do not need to be up high. They just need a way to get out of there, so they climb up and then fly off of the bridge. And also, some bats, including our western red bat, actually will bury themselves under leaf litter, especially if they're out and the night gets really cold and they don't have an immediate night roost that they know of. They will often fall to the ground and hide themselves under leaf litter. And then on the next warm occasion, they will walk, crawl to a tree, climb up the tree, and then fly off and then get back to their roosts. So, and yes, they can find their roosts very, very well. And if you look at the left side, for obvious reasons. Next. So we have problems. Sometimes bat roosts don't work out as well as we might think. Others just make for adorable photographs. That is a photo of the western yellow bat. If you notice, I've adjusted by saying that is our newest bat. I was doing an odd survey for a couple that just wanted to know what was in their yard, and not even expecting it, but got a recording, and I said, oh my goodness, that is the a recording of a western yellow bat. Never had been found along the coast any further north than Los Angeles County. And so now I've actually been finding them as far north as San Jose. And it's mostly because they move and like to roost in those giant desert palms. And they're a very big, very fast bat, so it's easy for them to move around. And it makes the 19th bat in our local cohort, 19th species of bat. Next. So here's where we get to what I was talking about before. So bats of the Central Coast, group 1, the Malacids. And if you look to the bottom, so first off, that's a Malacid up in the right-hand corner. It's obviously not a real dog. That's a Greek statue of a Malacid. And this animal is no longer with us, but closely related animals, including mastiffs, do persist. But that was the Malacid, and I think it's not that hard to look at. Mostly the guy on the left, who is a Western Mastiff bat. The jovial bat on the right is actually a Mexican free-tail bat. And it just goes to show that bats don't always have to be snarly or whatever. They basically have relatively adorable little faces. The mastiff bat is sort of interesting in the sense that those big ears help it detect the large beetles that it catches. So when it sends out ultrasound, it sends out low frequency. And so rather than, and it gets very, very good return on its energy output. And most of it is based on the proximity of those ears to the mouth, where it can get very, very close and grab the animal that it's, and they are specialists in large moths and coleopteran beetles. So our 4 species are the Mexican free-tailed, which is common, Western mastiff bat, which is rare, and it's rare because we don't have the habitat necessary. If you're in the right habitat, there's a high likelihood you will hear or see or record one. The pocketed free-tailed bat is actually one of our 2 newer species, probably preceded the Western yellow bat, but it's still rare. And I have found a couple of roosts, one of which is down near the Pozo, I guess it's the Pozo Bar or something. There's a Rinconada mine in that area, and the mine actually has several pocketed free-tailed bats roosting in there. And then finally, the big free-tailed bat, which I've denoted as a W, is a wanderer. I believe that they do occur here, but I have not yet found a roost. So I'm going to call it a wanderer. And when I say wanderer, this bat is a desert southwest species that has been reported as far north as British Columbia. So I'd call that wandering. All right, next. All right, so then this is not an official breakout, but the group 2 part 1, I just call them the larger evening bats. And so we have on the upper right, the hoary bat, and then on the left top is a big brown bat, and then on the right is a Western red bat, and then below on the left is a silver-haired bat, which I think you can probably see is a pretty good name. And so our medium-sized bats include the big brown bat, which is common and is the bat that we found at the house on Vine Street. Pallid bat, which in many parts of the state is a rare species, is actually doing quite well, provided we continue to maintain our oaks and open grasslands and old barns. The combination works really well for pallid bats. Western red bats are rare, but they're rare not for any specific reason. They're just a solitary bat. We don't have a lot of water. They like riparian corridors. We don't have a lot of that. Western yellow bat is uncommon. I find it, but it's not going to be found on every survey, even if you're in the right habitat. Hoary bat is everywhere but uncommon, and it's another solitary bat that's single. It roosts singly, like the one up in the upper right-hand corner. And if you're not familiar, the name hoary bat refers to that whitish tinge to the edge of the fur that is, in the poetic sense, the hoar of a early morning where the dew has turned to frost. And that's a pretty nice name for this bat. Silver-haired bat, also aptly named. The big browns are the most cosmopolitan, and they often live in attics, church belfries, and other structures. The red, hoary, yellow, and silver-haired, they're solitary bats. You will almost never find them in houses. You'll almost never find them in bridges and such. And then there's pallid bats, which are kind of everywhere, but nowhere in great numbers. Next slide. So then we have the smaller evening bats, And this is all part of, they're not all the little brown bats, but these are kind of all little brown bats. So the canyon bat, which is the smallest US bat, is actually more of a desert bat. And so along the coast, it's rare. But as you proceed inward, even when you get to places like the Carrizo Plain, it actually becomes one of the more common bats. California Myotis is common, often in association with Yuma bats, where Yuma bats forage over the water. California bats will forage along the edge of water along the shrubbery. Western small-footed Myotis, it's another bat like the canyon bat that's very rare on the coast, but once you get into the more desert-like areas, including the Carrizo, but then extending this way onto my desert studies, it's out in the desert. It is my most common bat. And then there's long-eared Myotis, fringed, and the fringed Myotis is sort of interesting. It just kind of goes to show that a lot of these bats aren't identifiable except for acoustic signatures, which you'll see in a bit. But if you look to the right, in between my thumbs is the uropatagial membrane of a fringed Myotis. And it's the only one of our local Myotis that has that little fringe of short hairs. And that's the kind of stuff you look for when you're identifying bats, even in the hand. All right, let's move on to the next. So obviously, it's the kind of thing where everyone always wants to know, okay, what do bats eat? So our bats north of southern Arizona, Southern California, meaning the extreme Southern California, where there are a couple of nectar feeding bats, fruit bats. All of our bats are insectivorous. So our bats are eating mosquitoes, moths, midges, beetles, bugs, grasshoppers, locusts, crickets, lacewings, mayflies, just an entire assortment. Some species, like Townsend's big-eared bat, seem to be moth specialists. When we get to a real specialist, we'll see it in the next slide. But they will also take scorpions, spiders, centipedes, and solpugids, and sort of interesting other ground-dwelling animals. But bats elsewhere, so this is not pertinent to our local bats. They will eat fruit, nectar, pollen. There are frog specialists, fish specialists, and some actually eat birds. And then, of course, yes, some lap blood from small wounds that they create in chickens and or livestock. There are no exclusive cannibalistic bats, but there are cannibalistic bats, and our local hoary bat, which is a very strong flyer, a very large bat, actually will on occasion take smaller little brown or the Myotis, the mouse-eared bats. And then there we go. There's only 3 species of vampire bats, and none of them occur yet in the United States. All right, next. So this is what you get to look at even in the hand, and I'm sure all of you could distinguish these two, one species from another, but I'm wondering if I let you handle them today and then brought you back in 3 weeks, you could tell me which one was which. The long-legged has the longer ears on the left and the more pointed snout. The little brown is on the right with the more rounded ears. Again, acoustic signature is really helpful. Having the animals in hand and taking measurements is good, but even in some cases, especially for instance, on some very closely related bats like California Myotis and small-footed Myotis, sometimes it takes genetic analyses to actually separate them out. So, but these bats were captured almost at the same time at a high elevation site I was working And I was using mist nets, which is how I got the photographs. But I mentioned this slide in particular, one to show these are brown bats. They're definitely different, but obviously they're also about 6 times the normal size. I stopped doing mist netting and use of harp traps, which I'm not going to talk about, but it's another method of capturing bats because they're very time consuming. And I figure I actually get, to me, 10 times the data per hour spent by doing my acoustic recordings. Other people would say, well, you can't just do acoustic recordings. And I would say, you are right. So let's let the younger folk do all the mist netting and the harp trapping. So next. So here we go, the picture part. So this is the California Myotis. Again, we have, I think I have slides for all 7 of the small brown bats. And Myotis means, or it's translated as mouse-eared, meaning they have small mouse-like ears, unlike some of the bats like the spotted bat or the Townsend's big-eared bat. So these all have relatively small bats. And so part of the reason I wanted people who are going on the field trips to be at this is to then see what's going to happen. Next slide. So this is what we're going to be seeing. And just in general, so there's all sorts of components. If you do a lot of bird song analyses, you recognize much of this. Not as complex as they are sending out single pulses, unlike if you, for instance, look at the sonogram of something like a lazuli bunting, you're not going to get anything that's, this may look simple, but wait till you see the next slides. But up at the top, we have an oscillogram, which helps distinguish. One of the things I'd point out, if you look at the strongest signals on top for the California Myotis, notice there's a break. There's 2 power centers. A smaller one on the left side and a larger one on the right. And it's not as visible in the smaller pulses. But the thing about the California Myotis, if you notice, this is a bat that's vocalizing at above 100 kilohertz. There's only 3 of our bats that get up that high. And why did I call it a 50 kilohertz bat? Well, if you look at the purple, not the bottom white dots, but if you look at the purple, across the spectrum, you'll notice that they all end somewhere around 50 kilohertz, which is that figure on the left-hand side of the screen. So in bat talk, California Myotis is a 50 kilohertz bat. Its calls are very short, abrupt. That's a time scale going from left to right, as opposed to the frequency going from bottom to top. And you'll notice that there's going to be enough difference that over time you would be able to, and hopefully that's what I do. At least that's what they pay me to do. And I get really excited because I love this stuff because it's not very easy. So it's like every time I sit down, I have a puzzle to solve. Next. So here's that fringe Myotis, and here's an even closer look at its little hairs. Notice even the animal in flight, you can actually see those, that fringe. And notice they look a lot like California Myotis. But how do they differ? Oh, let's look at the next slide. Ooh, look at that. It's a 25 kilohertz bat. So if I had 2 species, a fringe Myotis and a California Myotis, I could probably tell them apart, not by how they looked, but by their vocal signature. Notice, and it doesn't show up as well, but notice up in the oscillogram at the top, that distinct 2-part essence of the call is not present in the fringe Myotis. And notice how regular across the spectrum this is from left to right, from the start of the call to the end, and how they end at 25 kilohertz. And hence we call this a 25 kilohertz bat. Next. And here's the little brown Myotis, the one that's actually quite rare. And I put these in order because someone might say, okay, getting these things identified could be easy. Well, I put the 3 hard ones at the end. I put these so you could actually see that there's pretty remarkable differences. So when we look at the little brown, the so-called 40 kilohertz bat, it also gives us a little bit extra information because it has something called grace calls, which now, just before we go to the next slide, just think how many of you would want to be on the chopping block having to identify the 3 little brown species that we've already seen. Now you can see why. Let's go to my acoustic slide next. Because that's why I study them with acoustic equipment. And notice once again, here we are in the purple range. It's about 40 kilohertz, but these, so notice, especially look towards the center, towards the stronger calls. Notice there are the so-called grace calls in between. None of our other Myotis does this. They're at the same frequency, and I'm talking about lower frequency. They're also at the same time interval, and they are extremely regular in shape, and they are half the power that the primary calls that the bat gives out. So that helps identify those 3 very distinct species. All right, so then we go to next slide. Here's a long-eared Myotis, and this photo on the upper right is a great example because it's still a small mouse-eared type animal, but long-eared Myotis have the longest ears of any of our North American mouse-eared bats, our Myotis. And these are actually forest dwellers, and they are forest dwellers that prefer slightly drier forest. And I don't know how many of you know, but one of the best places to look for bats or record bats or show people bats is Dover Canyon, out Highway 46, near where we'll be taking the walk on Thursday. And there's 5 different habitats there, and it is very nice. Yes, some of the bat species overlap, but it's really nice to see where the long-eared Myotis are found in the drier woods. The one we're going to get to after this slide is the long-legged Myotis, which prefers moister habitats. And then we'll also see the pallid bat, which loves open grassland. And if you looked at my data, you would see the bulk of my long-ear calls, keeping in mind that bats do move. They just don't stay in the same place and hunt. They move around, and then they go from parts of the forest to another part. Most of my long ears are going to be in dry woodland. Most of my long-legged Myotis will be in moist woodland, and my pallid bats are going to be in oak woodland and open grassland. So let's look at what the long-eared bat calls like. So now you can start to see where it gets a little more difficult, because this is actually a 30 kilohertz bat. It's not necessarily as distinctive as if we had the fringe Myotis. But when you get consistent calls like this that are at 30 virtually the entire call, and yes, I've cherry-picked the calls to make them the best possible. And do we identify every call? No, I would say I probably throw away 50%. I don't throw them away, I store them, but 50% of the calls I record are not, I cannot identify them. No, they're not identifiable. So you look for the best when you're doing your identifications to ensure that you're actually making appropriate reports and noting where animals do and do not occur. Next slide. And here is that long-legged Myotis. Notice it also has fairly long ears, but hopefully you can see that relative to that image of the long-eared Myotis, not quite so long. Next. So here's another thing to look at. Notice that there's like a little knee. So this could be any of the 30, 35, 40 kilohertz bats, but unlike the California, the first one, which had a very dramatic down slope with very little curvature, notice that the long-legged Myotis, that 35 kilohertz bat, has a little knee right at the beginning of and that purple represents the maximum power of the call. Okay, next. And here is the Western small-footed Myotis. One of my favorite shots. Next, show what this bat talks like. So notice it's still pretty high, but one of the things about Western small-footed Myotis, if you notice that the calls lack integrity at the upper part, there's all those little dots. It means it's not putting out a constant amount of power. And again, that's something you should not necessarily know or even have to remember. It's just that that's the kind of things we're looking for. And I would call this typically a 40 kilohertz bat. Many of the ones here seem to be at 42 kilohertz, and that varies actually throughout the state. And bats don't have to have these regular calls. But as I said, I cherry picked the best to give you good examples. Next. And here's the Yuma Myotis. And this is the one, so if any of you goes to a pond and sees a little brown bat, especially if you see lots of little brown bats, flying over the surface, not necessarily drinking, but flying very close to the surface and darting along the edges and across and just not flying down and then leaving, but just flying around above a lake, a pond surface, is a really strong, like a 95% chance that what you're looking at is a Yuma Myotis. They are tied to water. I have places that that if you have a pond, you can record and watch Yuma Myotis. And if you go literally a half a mile away to an area away from the water, you will never record them. So let's look at, and I think at this point, let me just say something. Here's a shot, a rare shot, difficult, and I can even say, notice that most of the shots I've taken are pretty clean. It's really hard to get a shot of with that actually captures a bat capturing food. But this just gives you an example of the fact that this little bat is still eating a pretty good sized moth. And I think there probably would be questions at some point. So how do they capture prey? Well, they are pretty amazing animals. They can capture prey, and many do with their mouths, with their, grabbing them with those little sharp teeth. But they also capture flying insects by grabbing them in their wings and then transferring them to their mouths. And the best of all, actually capture insects in their tail membrane and flip the insects up into their mouths. That to me is the epitome of bat hunting. So in this case, it is more likely with that small bat and that large mouth that the bat actually caught the mouth in flight with its mouth. So let's finally look at the ultrasound view of the Yuma bat. And so here's a slightly higher, close to a 50 kilohertz bat, but notice that it too has a very slight knee, about 55 kilohertz, 56 kilohertz, and then all the calls stop at right around 50. So very similar to California Myotis, and in some cases you can't tell them apart, but in good call sequences, that knee will help distinguish them. All right, next. So here's the bat that I had mentioned earlier. Notice how much larger the ears are. This is a bat that many of you might have read about because it's a fairly well-known bat. It's probably the quintessential Central Coast bat. It's the bat that lives in or has night roosts in people's entryways and leaves all sorts of wonderful debris so that you can tell what kind of bat it is and you can tell what they've been eating. And it's also the bat that has been proposed as California's state bat. Someone earlier tonight mentioned that I know a fellow named Dave Johnston, who is a wonderful scientist, a bat biologist who works in the Monterey and Santa Cruz area. And he is the instigator of the Pallid Bat petition. So if you type in Pallid Bat petition in your web browser, you'll be taken to the petition. And if you would sign it, the Pallid Bats of Central Coast would be much appreciative of that. We need a state bat, and to date, there is support, but not enough. Incidentally, these animals have a couple of bizarre capabilities. One is they're immune to the sting of scorpions. And they also will echolocate to get from one place to another, but they hunt using their ears, listening for the rustling of crickets and scorpions and Jerusalem crickets. They call them potato bugs here, but I don't think there's many potatoes here. But they actually will dive onto the ground, capture, and they may eat them there, but typically if it's a large prey item, this is one of the 4 bats in the world that actually can run on the ground in order to take off. The other 3 happen to be vampire bats, which makes sense for that, the style of prey capture, which is blood, meaning they have to be sedentary when they're doing it. And so these animals grab their food and then we'll take it to your portico, whatever, your entryway, and they will do various things with the animals and eat the best parts and leave the rest for you. They're quite friendly. I have been working at a bridge where the pallid bats were just totally horrified that someone would climb up in a ladder and put up a detector and try to grab temperature data and such. And within 3 months, the bats actually stopped screaming at me when I would climb my ladder and would actually crawl towards me to see what I was doing. Bats are intelligent and they're highly inquisitive. And the reason they were afraid at first is because I would think I'd be pretty scary to a lot of things, including other people. Next. So here's what they eat, pallid bats. And many of you may have seen some of the remains of these animals in those areas that I earlier in the talk mentioned. There's so much to talk about, but this is just basically a summary of the bats. So I'm not going to talk about day roosts and night roosts, but those exist. And there's all sorts of wonderful things about how ultrasound works and that sort of thing. But that we probably should get moving on to the next slide. So this is the what you can do for bats. And I think earlier in the program, right at the onset, we'll do some Q&A, but if you have questions, I will answer them and I'll give them back to MCS so they can post them on their website if they so desire. And I'll also make sure I include this information because there's lots of little things that people can do. I've already mentioned bat blitzes, and I think most of you, if you're on this Zoom meeting, you probably are conscientious about our environment and the threat of climate change and such. But specific to bats, here are things you can do. And the next one has more of the same. But this one a little bit different in the sense that, you all know you shouldn't really touch any wild animal, well, unless you work for Project Wildlife, in which case hopefully you've been trained to do it appropriately. But For working with bats, so I'm immune to rabies. I'm also immune to hantavirus. Bats always get the bad reputation of being rabies carriers, which they are. But that doesn't mean all bats carry rabies, and it doesn't mean all bats show the signs of rabies. And if you don't touch them, the chance of getting rabies from a bat is kind of close to zero. I think there's another one. There were, questions. There's always questions in the last 2 years about COVID. So our bats do not harbor the virus that causes COVID-19. Actually, no bat harbors the virus that causes COVID-19. When we were all, as bat biologists, wondering what we should do at the time the pandemic erupted, the resource agencies decided en masse that they didn't want bats being handled by people because the bats could get COVID, which I thought was very a good decision and ironic. I have people ask me, "Oh, I don't want bats in my backyard because my cats are out there." And I actually love cats. I'm allergic to them, but I love cats. And cats have a place. They're domesticated animals. And I know I sound preachy, but when you consider, and again, with so many birders in this group, you know that cats just decimate bird and lizard and snake populations. And so cats are wonderful, and they're especially wonderful if they're indoors, or if they're in outdoor containers that are pretty safe for the cats and the wildlife. And you can do that if you really like your cat, or if you love your cat. Okay, enough preachiness. Let's go next slide. Just some more shots. People love shots of animals. And so upper left, that is a diving silver-haired bat, which you all probably could have guessed. The one in the middle is a big brown bat. I try not to have photographs with teeth, but it was the best shot of a big brown bat that I had. Notice the little tail nubbin. This is not a free-tailed bat. That's just a regular old Vesper bat with a little tail nubbin. And then up in the right-hand corner is a Townsend's big-eared bat, which I've mentioned before. And notice how large. So it is not a mouse-eared bat. It is not closely related to the mouse-eared bats. And that's the bat that roosts up in the Rinconada mine. Next. And so here are some of my favorites, including, once again, the happy little Brazilian free-tailed and the wonderful Mastiff bat. And that's not a face that only a mother could love, but definitely any bat biologist. All right, I think the next might be the last. There we go.